Assalamu alaikum. We are keeping this class for gravitation, and this is November 13, paper 43-1. And I'm starting with the first part. This is one of their favorite question. State Newton's law of gravitation. Newton's law of gravitation says that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the separation between the masses. The Newton law of gravitation says that the product of the masses is directly proportional to the masses and inversely proportional to the square of the separation between the masses. A star and a planet are isolated in space. The planet orbits the star in a circular orbit of radius r. This is our Cambridge language here. This is a common language using the word isolated in this chapter. Isolated means that multiple gravities do not act on it. This is November 13, 43-1. A star and a planet are isolated in space. The planet orbits the star in a circular orbit of radius r. The angular speed of the planet about the star is omega. By considering the circular motion of the planet about the star of mass m, show that omega and r are related by the expression. This is their favorite equation, Kepler's third law, where G is the gravitational constant. Explain your working. Now, when you start this derivation, Kepler law is based upon the idea that centripetal force is coming from the gravitational force. So work out with me. A small derivation is there. a small derivation, and this is according to Kepler's third law. The Earth orbits the Sun in a circular orbit of radius 1.5 into 10 to power 8 kilometer. The mass of the Sun is this. A distant star is found to have a planet that has a circular orbit about the star. The radius of the orbit is this much kilometer, and the period of the orbit is 2 years. Use the expression in B to calculate the mass of the star. We have the formula R cube omega square is equal to GM. Now, something we have discussed in our class, that ratio method can be applied on any case. You can make it one time you can write the formula with 1, and second time you can write the formula with 2. But I have to see that they haven't given me the angular velocity. Instead, they had given me the angular time period. So I will use a formula omega is equal to 2 pi upon t. I will make some derivation steps. So I have made these steps because time period, I have the time period. Now, what you have to do, you should try to make a ratio based formula, because 4 pi square is a constant, G is a constant. So I want to rearrange it, and I will say that R cube is equal to G upon 4 pi square into M into T square. So I can say that R cube is equal to a constant into M T square. I can use a ratio method. or I can use directly the formula. Now it's my choice. I need to find the mass of the star. Now you have to help me that what should I do next? Either I can use my ratio or I can use the formula directly. I have all the data. I have the time period. I have the time period. I have the radius in kilometer. I have the radius in kilometer and I have everything. So it's your choice. I have shown you both the steps. You can go for the ratio method. Interestingly, examiner has given data about the mass of the sun, and the radius of the earth also. So it's your choice now. Okay, you can do it by using the formula R cube is equal to G upon 4 pi square, and G is a universal constant. Mass you have to find. You need to find the mass. You need to make the mass. So both calculations are fine. So help me to calculate this if I take the formula. Remember to convert kilometer to meter. So this question can be done either by the ratio method, which I have done, or second method, you can use it. I show you here. If you do not want to do the one person is asked why ratio method is necessary. Look, ratio method is not necessary. I have to revise things, so I am doing it. If you do not want to make the ratio method, simply make m the subject and 4 pi square r cube upon g t square. You can use that also, but I have to show both because both are working here. Now, you know that radius here is 6 into 10 power 8. So it should be 10 power 3 into, and the G value is constant 6.67 into 10 is to power minus 11. Time period is 2 years, but I need to convert it. So please put all the values. One point six into 10 is to power 31 kg. I got one answer by now. Please, other people also share your answer. 3.2 10 power 31. Second answer is coming 3.2. Define gravitational potential at a point. Gravitational potential at a point is the work done per unit mass to move the mass from infinity to that point. A stone of mass m has gravitational potential energy EP at a point x in a gravitational field. The magnitude of the gravitational potential at x is 5. Relation between m, EP and 5. Actually, the formula is phi is equal to W upon m. W means work. I explained in a class that work done is actually potential energy. So you can write it like this. Potential is always negative. So if I write it in form of EP, would remember that gravitational potential is always negative. So now copy this formula also. Now read the next part. An isolated spherical planet of radius r may be assumed to have all its mass concentrated at its center. This is something like point mass. This is a definition. This is a definition similar to point mass. The gravitational potential at the surface of the planet is this much. So he has given us the value of phi. Stone of mass 1.3 kg is traveling towards the planet such that its distance from the center of the planet changes from 6r to 5r. And he wants us to find the change in gravitational potential energy. Now read the question. So if you have I have shared the formula list also today again. So if you people have to look on it, you can look on the formula, the change in gravitational potential energy. Delta U is equal to minus G M upon this is the formula. So now this is the formula, put the values. but I don't have the formula for the bigger mass. So I think we should work on the potential. Rather than this, we can work on the formula given above. Because I don't have the bigger mass. So I think we can't use this formula here because the mass of the source planet is not given. So we can focus on the formula EP is equal to minus phi into m. Phi is given. Gravitational potential at position R is given. So I can find the potential at 6R, I can find the potential at 5R, and then I can subtract it. So let's start for potential. What's the formula for potential? The formula for potential is minus Gm upon R. It means potential is inversely proportional to R. I have the potential at R, I need potential at 6R, and I need potential at 5R. Phi at R is how much it is? 6.3 into 10 to the power 7. So potential at 6R I have to divide it by 6. Then potential at 5R is minus 6.3, 10.7 upon 5. So I have now two potentials. Look at the formula which we have made. EP is equal to minus phi into m. When I need delta EP, I will be taking delta phi into m. Now I can minus the potential and multiply it by the mass. Mass is given here, but it is in kg. Convert it into gram. Acha, nahi, sorry. Phi is also in joule per kg. Kg is fine. Do not change it. It's kg, and then multiply and subtract it and multiply. Now you have to see the working. Copy this working, complete it, and get the answer for me. Okay, convert it into scientific notation, Zion. Please convert it into 10 power something. 10 power 6. Yes, it's coming 2.7 into 10 to power 6. June 14, 42.1. The mass of a sphere. Hello. The mass m of a spherical planet may be assumed to be a point mass at the center of the planet. This is always an assumption in this chapter. This is a common assumption in this chapter that the mass is a point mass. A stone traveling at speed v is in a circular orbit of radius r about the planet as illustrated. Show that the speed v is given by the expression this. This is their favorite Kepler law derivation. And as I mentioned in my regular classes that in A2 derivations are repeating. So centripetal force is equal to gravitational force. This is the first step of the derivation. And if you cancel it, then you can cancel r with r, one r as a variable also get cancelled. This is the derivation. Copy it. A second stone, initially at rest at infinity, travels towards the planet as illustrated. This is the second stone. And the stone does not hit the surface of the planet. Determine in terms of the gravitational constant and the mass of the planet, the speed v naught of the stone at a distance x from the center of the planet. Explain your working. You may assume that gravitational attraction on the stone is due only to the planet. It's an isolated mass case. This is a case of isolated mass. So think a plan for it. Initially, there was a stone and and the stone was orbiting. This is the first stone was orbiting, but this new stone is not going to orbit. It does not reach the surface. Maybe it's away and later it can orbit. So what we can assume here, the stone does not hit the surface of the planet. The stone is coming towards the planet, but not hitting it. Gravitational and the mass of the planet, the speed v. Speed means kinetic energy and separation means potential energy. So as the stone is approaching, its kinetic energy will increase. And there will be a loss in gravitational EP. When something is approaching the source, when something is approaching the center of a planet, its kinetic energy increases. So if I put the formula, half mv square is equal to, the formula for gravitational EP is gmm upon, normally it is r, but today here I have to see what should I write. Should I write r or should I write x? The mass m is cancelled from both sides. We need to find v naught, the subject. This is the formula based upon the idea that loss in gravitational potential equals gain in kinetic. Use your answer in part 1. use your answer in part 1 and the expression in A to explain whether this stone could enter a circular orbit about the planet. Now, these questions are always tricky. The part number 2 is asking that for a circular orbit, what is the condition? Remember that this formula, look at this formula which we derived, this formula. This is called the satellite velocity formula. If a satellite has this formula velocity, it will orbit. Now, we have made a formula which is exactly double of it, and in under root, it is double of it. So I can tell the examiner that my stone has a velocity the stone I have has a velocity under root 2gm upon x, while the velocity needed is precisely gm upon r. So v naught is greater than v. So answer would be no. Why the answer would be no? Because its velocity is high. Remember, in order to orbit in a circle, a precise velocity is needed, and this velocity is not available here. So we can say it will not enter into a circular orbit. So that's all for today. And we will inshallah continue this in our next class. Allah Hafiz.